Octet-rule. Cossel and Lewis in 1916 developed the important theory of chemical combination between the atoms known as electronic theory of chemical bonding. According to this, atoms can combine either by transfer of valence electron from one atom to another by gaining or losing, or sharing of valence electron in order to have an octet in their valence shell. This is known as octet-rule. Covalent bond. Langmuir redefined the Lewis postulations by abandoning the idea of stationary cubical arrangement of the octet and by introducing the term covalent bond. The Lewis-Langmuir theory can be understood by considering the formation of chlorine Cl2, chlorine molecule Cl2. The Cl atom, with an electronic configuration of 3s2 3p5, is one electron short of argon configuration. The formation of chlorine molecule can be understood in terms of sharing of a pair of electrons between the two chlorine atoms, each chlorine atom contributing one electron to the shared pair. In the process, both both the chlorine atom attain outer shell configuration, outer shell octet of nearest noble gas, that is argon. The dot represents electrons, such as structures are referred to as Lewis dot structure. So what this means is that these dots are which are surrounding oxygen. These dots are representing Lewis dot structure. Means from the basis, this figure, this compound is figure is made by using Lewis theory, right? Lewis dot structure theory can be written. The Lewis dot structures can be written for other molecules also, in which the combining atoms may be identical or different. The important conditions being that each bond is formed as a result of sharing of an electron paired between them. Between the atoms, each combining atom contributes at least one electron to the shared pair. So now what this means is that whichever like this carbon is forming bond, right? So at least it will at least give one electron for sharing. In covalent bond, that is a minimum need, but in future you will learn about coordinate covalent bond, in which only sometimes only one atom gives the both the electrons for sharing, right? Let us go forward. The each combining atom contribute at least one electron to the shared pair. The combining atom attain outer shell noble gas configuration as a result of sharing of electron. Thus, in water and carbon tetrachloride molecules, formation of covalent bond can be represented as. Thus, two atoms share one electron pair. They are also said to be joined by a single covalent bond. In many compounds, we have multiple bonds between the atoms. The formation of multiple bonds envisages sharing of more than one electron pair between two atoms. If two atoms share two pair of electrons, the covalent bond between them is called double bond. So that is why it is very understood. I need not explain that whenever they share, like if carbon gives two electron and oxygen also gives two electron for sharing, then they form a double bond, right? So now, for example, the carbon dioxide molecule we have two double bond between the carbon and oxygen atoms. Similarly, in ethene molecule, two carbon atoms are joined by double bond. Now, this is the figure of C2H4 molecule, right? This is known as ethene. This is known as ethene, right? Because carbon is forming double bond. It, now, when combining atoms share three electron pairs, as in the case of two nitrogen atoms in the N2 molecule and the two carbon atom in the ethene molecule, a triple bond is formed, right? So whenever triple bond is formed, that is known as ethene. Means not ethene, this ion comes, YNE. Right, let us go forward. Lewis representation of simple molecules. The Lewis dot structure provides a picture of bonding in molecules and ions in terms of shared pair of electrons and the octet rule. While such a picture may not explain the bonding and behavior of a molecule completely, it does help in understanding the formation and properties of a molecule to a large extent. Writing the Lewis dot structures of a molecule is therefore very useful. The Lewis dot structures can be written by adopting the following method. So these are the steps which you need to keep in your mind before making Lewis dot structure. And Lewis dot structure is very important when you see it from IIT or JEE aspect, right? Now these are the 5 points which you need to remember, right? That is good. Let me read it. The total number of electrons required for writing the structures are obtained by adding valence electron of the combining atom. For example, in the CH4 molecule, there are 8 valence electrons available for bonding, 4 from carbon and 4 from the 4 hydrogen atoms. Right. So what this wants to say that when CH4 forms a bond, then 4 electrons are given by carbon and 4 electrons are given by hydrogen, so they form a bond. this 4 electron which comes from hydrogen, it is from 4 atoms of hydrogen. For anion, each negative charge would mean addition of 1 electron. For cation, each positive charge would result in subtraction of 1 electron from the total number of valence electron. For example, for CO3 2 minus ion, uh, CO3 minus 2 ion, the 2 negative charge indicates that there are 2 additional electrons than those provided by the neutral atom. For NH3 plus, 1 positive charge indicates the loss of 1 electron from the group of neutral atoms. Knowing the chemical symbols of the combining atoms and having knowledge of the skeletal structure of the compound, known or guessed intelligently, it is easy to distribute the total number of electrons as bonding shared pairs between the atoms in proportion to the total bonds. Right. So, knowing the chemical symbols of the combining atoms and having the knowledge of skeletal structure of the compound, it is easy to distribute the total number of electrons as bonding shared pair between the atoms in proportion of the total bonds. Right. In general, the least electronegative atom occupies the central position. So this is an important point. Means the atom which has least electronegativity, that becomes the central atom. Right. It comes in the center position. And one more important point: this hydrogen and fluorine can never be like in middle. Like they can never be a central atom. Right. For example, NF3 and CO3 2 minus nitrogen and carbon are the central atom, whereas fluorine and oxygen occupy the terminal position. Right. Terminal position are the position which are like except central position, other positions are known as terminal position. Right. After accounting for the shared pair of electrons for single bonds, the remaining electron pair are either utilized for multiple bonding or remain as lone pair. The basic requirement being that each bond atom gets an octet electrons. So what this wants to say is that when we form Lewis dot structure, we always keep in our mind that each and every atom at least gets the like octet configuration. But that is not possible for every atom. But we try our best to give most of the atoms octet configuration, right? Because octet configuration will give them stability. Now these are the some of the examples. So now there's an exception for hydrogen. As hydrogen, like normally we see that octet is required for a compound to get stability. But for hydrogen, when it gets 2 electron in its outer motion, then it becomes stable due to duplet configuration, right? Because it gets a helium configuration, and helium is a noble gas, which is stable. Now, what is this problem saying? Write the Lewis dot structure of CO. So, what? How can we write the CO Lewis structure? How many electrons carbon has? Carbon has outermost electrons 4, right? 4 plus oxygen has 6 because atomic number 8 minus 2 6, which gives us total electron is nothing but 10, right? Now when carbon and oxygen forms this bond, this 2 electron already gone here, so how many left? 8. So 8 electrons are left. So better would be that 1 second, just change the color. So we can make 1 2 3 4 5 6 and 7 8 as a lone pair. We can give it to carbon, but even after giving the carbon, bond is not stable, right? So what we can do is that we can form double bond. If we form double bond, then this will go, right? Now we can also remove this and we can form a triple bond. Now what is happening? Both the atoms are getting stability. Oxygen also got stability, even carbon got stability. Look, carbon got 1 2 3 4 5 6 7 8 8 electrons. Oxygen got 1 2 3 4 5 6 7 8 8 electrons. So let us see the answer. What is the answer? Answer is same. I said they are forming triple bond. Look, both are matching. So this is the way to do, right? Now let us go forward. Write Lewis dot structure of nitrite. So this compound is known as nitrite, NO2 minus. Now how can we write it for nitrite? 1 second, I'll just open it. Right. So now what is saying? Nitrite. Right. This was right. What is it? NO2 minus, right? So how can we make nitrogen has 5? 5 plus 2 into 6. 2 into 6 plus 1 because it has a minus charge. So 6 is a 18. 18 electrons total. Right? 18 electrons. Correct? Now what we can do is that uh, just give me a moment. Now N O O. How many gone? Minus 4. How many left? 14 electrons. 14 electrons are left. 6 we can give over here. Correct? 6 we can go give over here. 12, 13, 14. But nitrogen did not get octet configuration. So we can remove this double electron. We can form this double bond. Now everyone got stability because nitrogen got 1, 2, 3, 4. Right? This is the figure for nitrogen. Let us see if we are correct. Yeah, we are absolutely correct. I just saw the answer over there. Look, we are correct. Right? So I would like to end this video over here because it has already become very large. So see you guys in the next video.